Hello students, welcome to classroom. I hope you are all doing well. In today's class, we'll be learning about refraction of light, the different mediums which are rare and dense, then the laws of refraction, and finally what happens to light when light enters from a denser medium to a rarer medium, or from a rare medium to a denser medium. So that will be the summary of what we'll be learning today. So let us continue with the class now. So, refraction. What is refraction, or what is refraction of light? So, the definition of refraction of light goes like this: the phenomenon of bending of light when light enters from one medium to another is known as refraction of light. So, let us write down the definition first. So, let us first write down the definition. Definition: the phenomenon of bending of light when light enters from one medium to another medium is known as refraction of light. So, if you read the definition, definition itself is very simple and very clear. Okay, it tells us what refraction actually is. So, it is the phenomenon or the process by which light bends. Now, when does light bend? The reason is also mentioned here. So, it is a phenomenon of bending of light which occurs when light enters from one medium to another medium. So, bending of light takes place whenever light changes its medium. Okay, so we are all familiar with this property of light called the rectilinear propagation of light, whereby light always travels in a straight line. But today, my dear students, today you remember one very important thing, that this property of light, this property of light where light travels in a straight line, exists only when light travels in one medium. If light happens to travel in another new medium, then what happens? Light will no longer follow the straight path, but rather light will undergo a bending, which will happen at the boundary between the two medium. So now I have been using the word medium a lot, so you may all want to know what is a medium. So the word medium has been used twice in the definition of refraction. So what is a medium? So what is a medium? So the definition of medium goes like this: any substance, any substance through which light can travel is known as a medium, So this is the definition of medium. A medium is any substance through which light can travel. So a medium is any substance through which light can travel. So can we collect some examples of medium? So examples of medium. Name some examples. Think of some examples of medium. What about air? Is air a medium? Can light pass through air? Yes, so air is a medium. Then think of some more. What about water? Can light pass through water? Yes, so that makes water a medium. Yes or no? Then can light pass through glass? Can light pass through glass? Yes. Okay, light can pass through glass, so that makes glass another medium. Then we have space or vacuum. Okay, so space and vacuum are synonymous, they are same. Okay, so what is space? The vast distance between the sun and the earth, okay, is nothing but space only. Okay, so the distance between the sun and the earth is filled by space. Okay, and light can travel through space. Okay, whereas sound cannot travel through space. Okay, remember that sound needs a medium to travel. Okay, sound, yes, light also needs a medium to travel, but for light, okay, light can even pass through space which has no particles in it, whereas sound cannot travel through space because sound needs particles. Okay, sound needs particles, whereas light does not need a particle. Okay, that is the reason why sound cannot travel in space but light can travel in space. So these are some examples of medium. Okay, air, water, glass, space. Okay, in all of these light can pass through, so these are all mediums of light. Okay, so now let's go back to the definition of refraction again. The phenomenon of bending of light when light enters from one medium to another medium is known as refraction of light. It's known as bending of light. So when does light bend? Light will bend when light changes its medium. Okay, when light changes its medium, light will bend. As long as light is in one medium, bending will never take place. Okay, this whiteboard, this entire whiteboard, okay, is one medium. So if my hand is a ray of light, then it will go straight like this. Okay, it will go straight like this. Okay, it will go straight like this. So considering this entire whiteboard to be one medium, the ray of light will travel straight. Okay, but along the way, let's say along the way, this is a new medium. So let's say we have two mediums. Let's consider the left side to be medium 1. Let's say this is medium 1, and let's say this is medium 2. Medium 2. Let me write here 2. So this is medium 1 and this is medium 2. So light in medium 1 is traveling like this straight. Okay, it's traveling like this straight. So let me just represent by drawing a ray of light. So it's drawing straight. Okay, I hope it is straight. Okay, so this is light ray traveling in medium 1. Okay, as long as it is traveling in medium 1, it will travel straight. Okay, but from here the medium is changing, so there is a change in medium now. Now the medium is changing, so this is a new medium. So when light enters through this new medium, light will no longer be able to continue its straight path, but it will undergo bending. So light will undergo bending and it may look somewhat like this. Okay, light will take this path. This is known as refraction of light, which occurs when light has to travel through two medium, which occurs because there is a new medium in the path of light. Okay, and as long as light travels in one medium, there is no bending in that one medium. Remember this class. Okay, I am repeating this again and again. As long as light travels only in one medium, there is no bending, but bending is observed when light travels, okay, into a new medium. When light has to pass through another medium, then we observe bending. Okay, we observe refraction of light, we observe bending of light. I hope we are clear. Okay, so let's continue with the discussion. So I will suggest you to take down the notes. Okay, so you can pause the video and then you can take down the notes, because notes are going to be very helpful for you in your exam. Okay, so let us continue with the next topic. We'll talk more about mediums. Okay, so this lesson is not so difficult. It's an easy lesson and I'm sure you all will easily follow. Okay, you will be following in the school also. Okay, let this be like a revision for you, so that your memory remains intact, because we humans, we forget easily. Okay, we tend to forget over time, so let it be a good revision for you. Okay, now yes, so we will continue more about the mediums now. So mediums are of two types, okay? So there are two types of medium. So there are two types of mediums. Which are they? Number one, we have rare medium, and number two, we have dense medium. So these are the two types of medium: rare medium and dense medium. Now let us learn what is a rare medium and also what is a dense medium. So what is a rare medium? A rare medium is a medium, okay, which has less optical density and in which light has more speed. Okay, a dense medium is a medium which has high optical density and in which light has low speed. Okay, means light comparatively travels slower here, whereas light comparatively travels faster here. Okay, so let us write the definition. Okay, so what is a rare medium? A medium having high optical density. Let there be a wall. Let us mark having high optical density. A medium having high optical density, comma, and in which light travels with more speed. With more speed. Now, what about the dense medium? A medium having, correction, that should be low. A medium having high should be here. Okay, sorry. A medium having low, not high, sorry. So a medium having low optical density. Rare is not rare. Rare, okay, means not much, okay, very few. Okay, that is the meaning of rare. Literally, the meaning of dense is having too many. Okay, a dense forest means there are lots of forests. Okay, whereas, okay, a rare forest means there are no trees. Okay, all cut down. So rare means having very less. Okay, very few. A medium having high optical density. High optical density. Having high optical density, comma, and in which light has, we'll just say low speed. Okay, light has low speed or less speed. Let us say less speed, not low, but less speed. Light has less speed. Okay, this is the definition which you can remember, with which you can remember a rare medium and a dense medium. A rare medium is a medium having low optical density and in which light travels with more speed. So imagine, okay, imagine a forest, okay, where the trees are less. Okay, since the trees are less, running through that forest or passing through that forest, okay, will be faster for you. Is it not? Will be faster for you. Then a dense medium, a medium having high optical density, that means the density is more, so the forest is very thick, so passing through the forest will take you a lot of time. You know why it's taking you more time? Because you are not able to move freely, because your speed is affected. You are not able to move fast because every now and then you bump into a tree, you face a tree, and then you have to walk away, you have to run away, you have to walk your way around the tree. So a lot of time will be consumed, your speed is affected. So here what happens, we find that you are moving slow. But here in a rare forest, from one end to the other end, you can easily move out because it's a rare environment. Okay, it's a rare environment, less obstacles, so easily you can pass through. Okay, got it? Dense means having more. Okay, so the particles are more. Let me shift to another example now. So the particles are more. Imagine a medium. Imagine a medium where the particles are more like, we can say, glass. Let's compare between glass and air. So we can say that air is rare. Okay, air is rare, and we can take the example of glass here. Okay, glass. So air, the particles are far away scattered. Okay, so there are few particles. Okay, when we take the example of air, there are few particles, so light can move faster in air. Okay, so that makes air a rare medium. Now when we go to the glass, we know that glass is dense. Okay, glass is very, very dense. So what happens is that light cannot move faster in glass because the medium is dense, because glass is denser. The particles are close together, the particles are compact. Okay, the particles touch each other, they are very close to each other, thereby light, okay, cannot pass through faster. Okay, rather actually the speed of light is affected, light is rather slow. Okay, in a dense medium, so the speed becomes less. Here, okay, here, because the medium is rare, okay, the speed is not affected much, so we see light escaping the medium or passing through the medium with a more speed compared to a dense medium. I hope we are clear between a rare medium and a dense medium. Okay, so very important, okay, to know what is a rare medium and a dense medium. Okay, so this definition will help you. So a medium having low optical density and in which light travels with more speed. Since it is a rare medium, light can move faster there. And a medium having high optical density, it has got high optical density, therefore light cannot move very fast there, rather light moves with a low speed or a less speed. Okay, example, glass. So between air and glass, if I ask you which is dense, your answer should be glass. Which is rare, your answer should be air. Okay, so now we go ahead, we go to the next topic, which is laws of refraction. Okay, so laws of refraction. Take down the notes, okay, class. So there are two laws of refraction, just like there were two laws of reflection. Do you remember the two laws of reflection? Try to recollect the two laws of reflection, how it was. Now if you recollect the two laws of reflection, the first law of reflection states that the angle of incidence is equal to the angle of reflection, and the second law of reflection talks about the angle of incidence, the normal and the point of incidence being all lying in a plane, isn't it? So that second law becomes the first law in the laws of refraction. So let us write down the laws of refraction now. So laws of refraction, very important. Okay, class. First law, the incident ray comma the normal to the point of incidence, the normal to the point of incidence and the refracted ray comma they all lie in the same plane. All right, so let us draw a diagram here. Okay, so let us try to understand refraction in detail now. So let me draw a surface here. Okay, I hope it is straight enough. So this is the boundary, this is the boundary. Okay, this is the boundary. Let me write here the boundary. What type of boundary is this? This is the boundary between the two medium. So above the boundary you have one medium, below the boundary you have another medium. So let us say this is medium 1, and let this be medium 2. Okay, so we have two mediums. Light will first, okay, enter from the medium 1. So this light coming down from the source is called the incident ray. So let us draw the incident ray. Where should I draw? Okay, okay, anywhere I think. Let me just draw here then. Okay, I have to think. Then if I draw like this, normal. Okay, so let us draw like this. Okay, so this is the incident ray, IR. Okay, so you can write here IR equal to incident ray, IR equal to incident ray, comma. Now the incident ray lands on this point. This point becomes very important. Where does this point lie? This point lies on this plane. What is this plane? This plane is the boundary. This plane is the boundary. Okay, so the boundary between the two medium, okay, is considered a plane. Okay, just like the boundary between water and air. Okay, so that is considered a plane. So this boundary is considered as a plane, just like in the first law of in the laws of reflection where I use my exam board. Okay, imagine the same scenario. So this is a plane. Okay, a plane is any flat surface. So this boundary here we are seeing in two-dimensional, but in reality it is a plane. Okay, so this is the point of incidence lying on the yes, lying on the plane. Okay, lying on this plane. So this is the point of incidence. Let's say point O. Okay, let's say point O. So O is the point of incidence. O is the point of incidence. Point of incidence. The point of incidence is where the incident ray lands. Okay, touches the medium. We can also say where it is the point where the incident ray touches the boundary. Now, from this point of incidence, what we do is we will be drawing an imaginary line which is called the normal, is it not? Normal is an imaginary line. Okay, and this is drawn to find the angles. Okay, we draw the normal because there will be angles here, angle of incidence, angle of refraction. To find those angles we need to draw the normal. So how do we draw the normal? The normal is always drawn perpendicular to the boundary. So draw a normal perpendicular to the boundary. Okay, let me try to draw mine. I hope it's perpendicular. So this is the boundary. Sorry, this is the normal. It is perpendicular, okay, to the boundary. Now then from this point of incidence the refracted ray will emerge. Okay, it will emerge. So let me make it bend towards the normal. So bending towards the normal means it will see, if there was no medium 2, okay, suppose the entire thing was just medium 1, then how will the light ray travel? The light ray will travel, okay, without any refraction. It will travel straight. It will continue its path like this. This is how light will continue. Okay, okay, if the entire thing was just one medium, because we know that in one medium, when light is traveling only in one medium, there is no bending, there is no refraction. Refraction takes place when light changes its medium, isn't it? So if there was no medium 2 and if the entire thing was just one medium, then light will continue its path. Okay, but it will not happen. Why? Because we have another medium, is not. So this is medium 2. Now light is about to enter the medium 2. So this will never happen. Okay, remember, this will never happen. This is never going to happen. So this will not happen. Okay, you don't even need to draw. I'm just drawing to show you. Okay, to show you. Okay, because I'm gonna tell you what is bending towards the normal and bending to away from the normal will look like. So now here what will happen? This is normal. So this is normal. Okay, and we can say n bar. So n is equal to normal. Okay, these are some important terms that we are writing. Most of them are repeated from loss of reflection, so you may know some. Okay, then let me show you. Okay, let me show the refracted ray bending towards normal. So if I were to show you the refracted ray bending towards normal, then I will be drawing it like this. Okay, like this, between this and this. Okay, so it will look like this. This is how I will show you. Okay, so this is the refracted ray. This is RR. Okay, refracted ray. So RR is equal to refracted ray. All right, now this is the refracted ray. So see, bending has taken place, refraction has taken place. Light was traveling like this. Okay, and it was supposed to go like this all the way, but no. On entering a new medium, medium 2, light did not take this path. Light took a new path. Okay, light took a new path, this path. So have a look. Okay, light took this new path. Okay, light has taken this new path. So light has underwent bending. So you can see, okay, how the light ray has bended. Okay, this is what refraction is. Okay, bending of light. When light enters one medium to another medium, whenever light changes its medium at the boundary between the two medium, bending takes place. Okay, remember that. So now the angle will be, one of the angle will be here. This will be the angle of incidence, because this is the incident ray. So angle I equal to angle of incidence, and angle here between the normal and this ray, this is angle R. This is why we draw normal, is not, because we need the two angle line, angle R, and this is angle R, which is angle of refraction. All right, so basically this is what you need to know about refraction of light. Okay, now we have the next law. One law is done. Now we go to the second law. The second law is the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant, which is expressed like this: sine I by sine R equal to constant. So this is the second law of refraction, okay, which says the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant. We can have a look here. Ratio means division. So the statement clearly says that to divide, okay, divide the angle of incidence to the angle of refraction, okay, the sine of the angle of incidence to the sine of the angle of refraction. Okay, on dividing we will be getting a constant. So this is the second law of refraction. We will come back to this one, okay, very soon, once we have discussed about refractive index. So right now we will just keep it here, okay, but the statement you have to study. So it's a simple statement. To understand this, okay, I will first have to explain to you refractive index, then it will be more clearer to you. So once we do that, I'll get back to this again. So But now you write down the second law of refraction, which is the ratio of the sine of the angle of incidence, the ratio of the sine of the angle of incidence to the sine of the angle of refraction. That means angle I value is divided by angle R value. Angle I value divided by angle R value, okay, it's a constant. Okay, sine, trigonometry, you're in class 10, you are studying trigonometry. So sine, cosine, cosecant, okay, trigonometric ratio, sine, it is taken from there, sine. Okay, so these are the two laws of refraction. Now we go to the last topic, which is what happens to light ray when it enters from dense to rare medium and from rare to dense medium. Okay, so let me erase this. The next topic, what happens to light when it, we'll just say, changes medium, changes medium. So we will discuss it in two forms. So let us make a division here. Now first we'll learn about when light changes medium. So when light enters from, what happens to light when it changes medium? That means when it enters from one medium, then it enters to another medium. So here we will be talking about what happens to light when light enters from rare to dense and from dense to rare. So first let us talk about dense to rare. So dense medium to rare medium. Okay, let this be the one here, and here we'll write when light enters from rare medium to dense medium, opposite of the first one. So let us try to understand this. You need to understand this, all of you need to understand this. This is very easy. Okay, now so here the incident ray enters from dense medium and then it will refract to rare medium. So let us draw the two mediums here. So let this be the boundary. Okay, then let us draw another boundary for this side also. Okay, now let us draw the incident ray. So let us say the incident ray will incident here. Okay, we'll make the incident ray enter incident here. So this becomes the point of incidence. At this point of incidence, okay, let us draw the normal and ready ourselves. Okay, and then light enters from dense medium to rare medium. So this is dense medium. Okay, so this is dense medium. Above the boundary, this is dense medium. So below becomes rare medium, where the light will refract to. This is the rare medium. Rare medium, remember, in the definition of rare medium, light travels faster. Okay, light travels faster in rare medium. Okay, and in dense medium, light is slow. Okay, so now let's see how will light undergo. So I will draw the incident ray. Okay, this is the point of incidence, so the incident ray has to land here. Okay, from advance I drew, so it will end here. Okay, so let us draw it. Okay, so let us draw it like this. I will give you a good picture. Okay, so this is the incident ray IR. Okay, this is the normal. So between the normal and the incident ray, you will get your angle of incidence. Okay, some things which you know, keep revising them again and again. Now incident ray is at dense medium, and now the light will, okay, the light is entering to a rare medium. So we want to know how will light undergo bending. So how will light undergo bending? Here, remember class, you have to just remember two things. Either it will bend towards the normal or away from the normal. Okay, I repeat, you have to just remember two things. Whenever light changes its medium, you have to just remember two things. Okay, two simple things. Will it bend towards the normal? Will it bend towards the normal? See, without this, if there was only one single medium, light will be traveling this. Light will continue its journey like this. Okay, this is how light will continue its journey. Had it been only one medium, but we are discussing two mediums, so this will not happen. Okay, normal is here. So now, will it bend towards the normal? Which means, will it be like this? Will the refracted ray be like this? Or away from the normal will be like this. This can be away from the normal. So what is the answer? Will it bend away from the normal? Will this be the answer? Okay, or will the refracted ray be like this, towards the normal? What is your answer? So when light enters from dense medium to rare medium, light bends away from the normal. So away from the normal, so the light will bend away from the normal. So light will bend away from the normal. Okay, see, bending away from the normal is not normal is here, bending way far. Okay, away. So this is the angle of refraction. Okay, so you can write here, when light enters from dense medium to rare medium, so we can write here, so when light enters from dense medium to rare medium, from dense medium to rare medium, it bends away from normal. Bends away from normal. Okay, so this is what we have to remember. When light enters from dense medium to rare medium, it bends away from normal. Alright, now we continue here. Now we will do the same thing. So let this be the point of incidence. Okay, somehow, okay, identifying the point of incidence makes the diagram look more better. Okay, so then from this point of incidence, we will be doing the normal, isn't it? So let's do a normal. Let this be the normal. Okay, now this will be rare medium. So the first one is rare medium. This is rare medium, and this is the second medium is dense medium. Okay, we can also write medium 1, medium 2. Okay, this is medium 1, medium 2, medium 1, medium 2. Okay, now how will I draw the incident ray? So again, I will draw the incident ray like this. Okay, this is the incident ray IR. Okay, this is the incident ray IR. This is normal. Now in the previous case, the incident ray entered from dense medium, and then okay, it had to go to a rare medium. So how did it undergo bending? It bended away from the normal. Okay, so when light enters from dense medium to rare medium, it will bend away from the normal. Okay, it will bend away from the normal. Now when light enters from rare medium to dense medium, the opposite will happen, which will be, it will bend towards normal. So it will bend towards normal. Okay, it will bend towards normal. Alright, it should be straight, so let it just end like this. So it will bend towards normal, so it's bending towards normal. This is the angle of incidence, and this is angle of refraction. Okay, so this is it. Okay, this is it. This is basically it. Okay, so this is what you need to know. Okay, when light enters from rare medium to dense medium, light bends towards normal. When light enters from a dense medium to a rare medium, light bends away from the normal. Like I said, you just have to remember whether will it bend towards normal or away from the normal. So let us complete this one. So when light enters from rare medium to dense medium, it bends towards the normal. So it bends towards the normal. Alright, so I hope that you all understood something. Okay, it is not a very difficult topic, it's an easy topic. So we will end the class from here. You can always go back and rewind and rewatch the video, okay, for better understanding. Okay, so I'll see you again in the next video. Until then, take care and God bless you all.